for the opportunity to just color in around this presentation that we've provided previously. So obviously we're not going to repeat word for word what's contained in the document, but try to color in around it and the nuances that you can't really pick up in a presentation like that. So this was the biggest ones of greenfields building for WeBuyCars since they became a proper business. In the past they used to occupy spec buildings and other buildings and then sort of turn them into facilities that they can use. But obviously with the exponential growth and the success of Faan and his brother who started the business, I was involved with the first greenfields project for them, and we were part of the team developing the brand and also the system of how they operate, and we had to also grow with them. The way that they washing cars and prepping cars for their facilities also changed over the years. So, and we were lucky to be part of that process. This building represents the latest facility, and like I say, the biggest greenfields project to date. The dome in Johannesburg is the biggest project that they've ever done, but that was an existing building. So, and what's unique with this one is there's a separate building that's still under construction, which is dedicated to prepping and washing cars. But the building that we were nominated for the awards is this one in screen, and it sits in a very interesting part of Cape Town. And I think that's why we're so proud of this building. Is it contributes on a number of levels. So Frankie, you can maybe give me the mouse. So as you all know, the client is WeBuyCars. The main contractor was Abidale. We were the architects, and I think the prominent consultants on this project was De Villiers Consult, which is the structural engineers. As you can see where it lies, it's actually in Wetton, but the client strategically wanted to call the building Lansdown. It's sort of on the periphery between Lansdown and Wetton, but from a marketing perspective, they preferred the name Lansdown. So this facility had to house 1,300 vehicles under roof, and the challenge that they've got in the Cape is that the weather just is a big consideration. In Gauteng, they do have facilities where they park cars outside and they sort of just dust them off. But in the Cape, they have to build buildings to house them. Otherwise, they just clean cars every single day. But what was also unique to this one is that we had to future-proof it. So all the other facilities we've done in the past was 100% dedicated to a motor mall, if you want to call it that. So the floor was designed to accommodate vehicles and so on, and the height of the building was also limited. With this facility, they asked us and the engineers to specifically future-proof it so it could become a distribution center for a ShopRite or Massmart or the like. So the floor and the structure and the height of the building was designed in such a way that it could be utilized in future as a different use. So from an urban design perspective, we had quite a challenge to convince the city that we're not building a factory or a warehouse or a cold, impersonal building on an extremely prominent corner of Governor Mbeki Road, opposite a shopping center. And the big challenge for the city was that they were building a bus rapid transit system, the BRT system, which they have convinced the city to spend the money on. and they needed now to support this infrastructure by creating trips and by creating traffic and the like. So we had to convince them that this building would meet the standards and would support the system sufficiently. I was in a committee from the private sector that advises the urban design committee from a developer's perspective, and it was actually quite a great process to also, from a developer's perspective, give the city insight to the challenges that developers are dealing with financially and logistically. And so the city comes up with these beautiful urban design principles, which is not executable in a feasible project. But here we work together, and we've actually managed to, I think, create a building that's very successful in terms of addressing the urban design requirements, as well as the logistical requirements of the client. So we had to create an interface for the building with Covenant-Becky Road. So you'll see that there's a substantial amount of glass, and we also placed all the functions like the coffee shop, which in this case is a Vida E-Cafe, on Covenant-Becky Road, and so that there's an active edge and an active interface. And then there were also several pedestrian access roads or access points from Covenant-Becky into the site to support that person who arrives with the bus. So staff for this building and even visitors, if you are going to pick up a car, you can use the bus rapid transit system, or if you sold your car, you can leave your car behind and get on the bus and then connect into the city's network again. So I think it's very unique in that sense. All the other WeBuyCars buildings, I think, in the country is almost like islands where, it's a destination. You drive there, it's like going to a motor mall, where this one is integrated into the urban environment. So the challenge with a building accommodating cars, but that also have to turn into a possible warehouse in future, is the structural grid and the spans that you need to achieve. So everything here is obviously based on parking bay dimensions. So that was sort of the driver for setting out the grid and for organizing the spaces and the flow of the building. So everything is worked out in increments of 5 meters. And then the engineer will elaborate on the structural system, when we carry on with the presentation. But it results in quite a long span that you need to achieve. And that was the driving force for the dimensions of the building. And then obviously we had the constraint of the 2 roads that we building the building within. And so it's essentially, it's a very, very long structure, which has got its own challenges in terms of movement. And then we had to accommodate the specific dimensions of vehicles and all the subsidiary functions within these constraints. So the project was completed December last year. In fact, it wasn't the 1st of December. On the 24th of December, the day before Christmas, we had a fire inspection with a fire chief, which was quite a unique experience. And it's a metal-cladded structure, essentially. We've got very low brick walls, but those were essentially just to create a physical barrier between the cars and the structure. But above this wall, which is 1.5 meters high, everything is cladding and metal structure. So the architecture we started to develop for WeBuyCars is obviously that prominent orange eyebrow, as we call it. But we wanted to soften this building in the urban landscape. And so we brought in automotive inspiration lines, of which we'll discuss that a little bit later in the presentation. But the lines of the building and the glass and those things were inspired by automotive design. So the sector is quite an interesting discussion, because is it warehousing? Is it showroom? Is it retail? So I never quite actually know where to classify it. But in our office, we'll classify it as warehousing. The project overview is basically what I discussed, and you can read it in depth in the presentation. So on the bottom right corner, you'll see the picture, an axonometric view from Governor Mbeki side, and you can see the eyebrow wrapping around the corner, basically welcoming visitors to the building. And you can see several boxes on the facade on Governor Mbeki Road, of which the middle one is an active edge. It's a coffee shop with a pergola, with beautiful views of the mountain, and it faces north. So it's actually a very pleasant space. And then you create this active surveillance, which the urban design guys love so much. This pergola is also a steel structure with sort of a steel louvet system over the pergola. Then the other boxes are glazed openings to open the building up to the road and to display some cars, and to make it look more like an office building, also a retail building, more than a warehouse or factory. Then the other thing you'll pick up is that it's becoming a signature of our office is the rounded corners. So the building sits, in our opinion, very softly in the landscape because of these rounded corners. So there you get an idea of the structural framework, and 371 tons of steel used in the project. The engineer will elaborate on that. And the cladding's 114 tons. We use the Youngman diamond deck profile, so AZ150 roof sheet, and you can see the cladding numbers. It's 21,000 on the horizontal and almost 7,000 on the vertical. Like I said, De Villiers consult with the structural engineers. They've also done the other WeBuyCars buildings. So as with us, they developed with the brand and try to innovate on every new project and try to find new ways of making this building more efficient. And one of the core values of WeBuyCars is tomorrow is not another day. So that was one of the values that we had to take into consideration with this project. With them, it's all about speed and about efficiency. So the design, other than designing the proportions and the flow around the vehicle and the functionality around that, was also speed. And then I would say the third layer was the urban design and the aesthetics component of the building. I'm going to hand over to Michael now to just run us through the structural system and the framing principles. And then Michael, you can just say, then I'll skip to the next slides.
Yeah, sure. Thanks, Ron. Yeah, well, I mean, like you said, we've kind of gotten used to the way of WeBuyCars working, and the one principle, like you said, this is the date we're starting in about 3 weeks or so, and then let's get running. So that's something you really can't achieve with anything other than steel. And especially for a thing like this, I mean, your critical path is getting a floor in, which means we need to get the steel up so we close the building. So one of the principles is just getting the steel in the air, which was facilitated by completely decoupling, which is essentially the whole long length of the building, which has a mezzanine tied into it, which you can only really do with steel. So that, I mean, like we discussed, the speed of which we need to get this up, you can't do with anything else than steels. And then the future maintenance, the future use of what we need to do dictated that we need a couple of big clear spans internally, which does then match up with a parking grid, which was figured out by the architect. So that resulted in one direction we've got about 15-meter grids, and then the other is about 20 and 25 intervals going over the full width. You can maybe just go on to the next slide. I mean, I think it was asking on how the load path works. The gravitational load path is pretty straightforward and standard. It's just purlins to trusses to girders to columns down, which is that's pretty much the only way to do it. And then a couple of other smarts we tried to achieve was to avoid excessive brace space and things, again, to just simplify where we can have openings in the sides and those type of things. So essentially the whole building is stabilized by columns cantilevering out the side, but also sharing the load to the other side. So through the steel roof truss, you can apply wind to the one side, it pushes over through the roof, it pushes onto the other side, which helps with some of the stability. That works in both directions. To reduce some of the bracing cost in the roof. What is this one is about? What was most technical we had to do is just get it up in the air quickly, and obviously light and as much as possible. So I think maybe over to the next slide where we actually applied some, let's call it some smarts, but having the option with steel is we're building this thing in any way, so we can shape it whatever shape you want, so we can geometrically optimize the shape of a truss to get us much more even top and bottom chord forces, which allows you to have less wasted steel, because we need to do a section in any case. So we make that so the chords stay optimal by just geometrically shaping it slightly to match what a bending moment would be in a typical roof, which is indicated in that picture on the side. So that's a bit of call it engineering smarts, and that helps get us to better tonnages on the steel roof to keep it light. The additional things it's probably just the high yield strength purlins, which is lately nice and available in Cape Town and the region. So jump on that to get the roofs down, and then it's the other smarts is essentially just some good old hard work in optimizing each truss for each wind specific load case. So it's not just a one span and you get 20 of them. I think we've finished out at about 15 different truss variations that all slots into specific wind catchment zones as per the codified loading designs, which just we don't have anything excessive that shouldn't be there, and everything works just as good as it should. And then the same thing for the girders. It's not just one span, one design. It all scales into specifically where required for the winds. And I think that's pretty much from the structural side, the smarts we applied in terms of what was required.
Great. Yeah, thanks, Michael. Yeah, just some of the specifications which is available in the brochure. BlueScope steel, colored bond, 0.53, AZ150, with a Springlock 700 profile by Youngman Roofing. What's unique about this particular structure is the polycarb. So all the white lines on the roof you see here is the opal polycarb sheeting. Now this is a thing we developed with the first building, and because the light quality of the cars are magnificent where you have these. So obviously in Gauteng they use very limited light sources on the roof because it's a different heat load and a different environment, and there's more movement of the sheets. But in this case, we've got almost a third of the roof that is in the opal, letting natural light through, and it creates a fantastic difference on the way the cars are presented. Other than that, it also reduces electricity cost because of all the natural light. You can literally almost keep the lights switched off during the day. Now, all of these had to be integrated into the structural system, and there is full protection design also under all these polycarb sheets, because they're obviously not as strong as the metal roof sheets. And then the interface of all the glazing and the eyebrows that you see there, integrating that with the steel structure and the different glazing systems were quite a challenge, but it's something that we enjoyed. Speaking about the automotive sort of inspiration, obviously the rounded corners, and then the GT stripes, as we like to call them, as visible on the top slide. It's a very, very simple system that we use, where it's a top fixed, so it's a flashing profile that we bend. So it's not a very complicated thing to achieve. You apply the flashing on top of an installed sheet, and you minimize the risk of any waterproofing and no complicated details during construction. But it delivers a very, very powerful visual effect in our view. Then the natural light that I described previously was also achieved by using it on the southern side of the building, on the vertical. As you can see there, it's actually a view of the back side of the warehouse, and it's completely light, and this was even during construction. The other detail that we're very proud of, that we developed over the years and applied in a few projects with De Villiers Consult, is the concealed downpipes and gutter detail. And it's a detail that we developed in such a way that clients are actually not scared to use it, although in essence, it could be seen as a box cutter. And usually, if you mention the word box cutter, people run away. But the whole detail is designed in such a way that the sheeting lip, or the sheeting finishes under the gutter, and the gutter forms a lip which becomes the flashing for that particular facade of a building. So if the gutter overflows, it overflows on the outside of the building onto the sheeting, as any roof would do. And then on the inside, we've got the downpipes running straight down, and we conceal these in brick boxes, which is then also just protecting these PVC downpipes from any damage. But it creates a very clean facade. Imagine if we had this facade with a bunch of downpipes on them. We wouldn't be able to achieve this curved corner. You would have to penetrate that eyebrow, and the entire visual effect would be completely different. On the bottom, you'll see an image of when they started moving in cars, and the tremendous light quality that you get from the semi-translucent roof. So Premier Roofing, sorry, we didn't include it in that. We'll just send a sub note, but the Premier Roofing was the roofing supplier, and the contractor was Mazor Steel. And like Michael said, because speed is of the essence, there's a tremendous amount of coordination that needs to take place in the fabrication stage, because these things are delivered to site and bolted together. So the accuracy of the cast of the columns and the design and the coordination gets exposed the day you deliver these on site and you start to assemble the roof. And this was done very successfully on this project. Just some pictures and some background on the logistical access and constraints, because they were also building the BRT system and upgrading all but one road surrounding the project. So it was quite a challenge. There you can just see the methodology of the construction, and we had to construct the building from that side because of the town planning regulations, which we started on an earth which already had rights on, and then got approval because a third of the building sits on a different earth, and it was still in the process of being consolidated and rezoned. So we started on the portion of the earth that we had rights on, and that's what determined the sequence of this building. So WeBuyCars is a brand that develops all the time as they grow, and we've learned how to accommodate new requests, new technology, and new systems that they bring into the design. And this building is highly flexible in terms of that. So the main challenges was this 2,500 square meter mezzanine, 240 meters in length. It's the length of the building. It's a post-tension structure, which also had to be done incrementally as the building progressed. And then the program, obviously, with any first floor structure that's cast in situ is quite a challenge. And then we've spoken about the vehicle requirements, ramps that needs to be a certain angle, dimensions, roads, circulation, the delivery of stock, the cleaning, and the whole process of scanning a car that's coming into the warehouse, getting it inspected, then it gets washed, then a picture taken, and then given a specific parking bay in the warehouse. That entire flow has to work like clockwork. Then another benefit just worth mentioning is the social contribution. There's over 300 people that works in this facility, and specifically for this part of town, makes a huge social contribution, which we're very proud of. Obviously, during construction, a structure like this employs a tremendous amount of workers, but then on the long term, operating this facility, like I said, over 300 people required to keep this facility going. I think the benefits of steel we've touched on already. It's the long spans, the clear spans that you can achieve, and you can just see the rows of cars that you can accommodate directly as a result of the structural members that allows that. So it's the clear spans, it's the speed of construction, and optimization of the building footprint on this site. Then obviously the maintenance and adaptability of steel in combination with concrete is unparalleled. So we have a rigorous quality assurance process that we demand from the contractors, but also from the consultants team. And that is done continuously throughout the project. And we use tools like drones to inspect roofs and even structural systems. But every bolt and every system in this building is inspected continuously. The contractor, Abidal, is highly experienced in this type of structure, and it was an absolute pleasure working with them in terms of getting the structure erected within tolerances. So Michael spoke about the optimization of material. So because they're not lazy engineers and they designed the trusses to fit the specific locations of the building and to optimize the sizes, you save on a lot of material, which obviously is very sustainable. Then also I think the speed of construction is also sustainable in terms of turning a piece of undeveloped land around as quickly as possible to create work and to provide to make a contribution to the environment as soon as possible. And then we've got a water recycling facility on site. The polycarb sheeting, like I said, is sustainable in terms of energy efficiency. Then there's also a PV system installed to support the electrical demands of the building. And then the urban design response, I think, is also quite a sustainable quality of this building to interface with the public in that way. In summary, the social connection, the architecture of the building, those details that we discussed previously make us very proud of this building, and the sustainable aspects of it, and which is all made possible through the use of steel. I think if we try to consider other alternative materials, brickwork, even precast concrete, then we wouldn't be able to achieve this result. Thank you very much.